Don't care Karnaugh maps are useful to determine a boolean expression where some of the inputs may be invalid. So for example, in some digital circuit codes, such as binary coded decimal, which is also known as 8421, where some of the outputs will be invalid for different inputs containing 4 bits. So when given an incomplete I/O table or truth table, we'll put X's to complete the table. And now we can draw the Karnaugh map. So for x, y, z being all 0, we have the x complement, y complement, and z complement having an x. And then x complement, y complement, z has a 1. And then x complement, y, z complement has an x. And then we ignore the 0 outputs when constructing our Karnaugh map. And then x, y complement, z complement has an output of 1. And then x, y complement, z has an output of 1. And then x, y, z has an unknown output x. And then using our typical Karnaugh map algorithm, we circle as normal, treating the x's as 1s. So effectively we're choosing the minimum number of blocks that cover the 1s, as we did before. So this x only has one adjacent element, so we circle this as a block. And similarly this x also has one adjacent element, so we circle that as a block also. And then the uncircled ones are in a block of 4. So we retain the x's included in the blocks that contain 1s. So we keep this x, and we keep this x, and discard this one. So for this block of 2, we have x being common to these two elements, and also z. So that has a boolean expression of xz. And then for this block of 4, we have the complement of y being common to those elements. So this is the expression representing our function. And then from this minimal expression, we can construct a disjunctive normal form. So we have x by y plus its complement by z plus x or its complement by y complement by z or its complement. So distributing x and distributing the complement of y, then we can expand this and simplify. So we have x, y complement, z plus x, y complement, z complement, and then plus x complement, y complement, z, and then plus x bar, y bar, z bar. And this term, or this term, is going to be the same. So we can get rid of one of them. So this here is our disjunctive normal form for our minimal boolean expression.